All set.
All right, thank you. Thank you, Robin. So team, welcome everyone. Welcome to another session from Mighty eLearn. Thank you for being here. My name is Karthik and I'm very glad to introduce you to Robin Goldsmith. Robin, as a quick introduction to him, is an author of many popular books on testing, books on proactive testing, books on real ROI, and beyond and so on. In fact, I will let Robin introduce himself much more in depth and what he wishes to talk. But I would definitely want to say that he brings a lot of qualifications on both areas of technology and management. He has worked thoroughly under phases like requirement analysis, quality, testing, project management. He has also worked significantly on leadership, metrics, overall process improvements, ROI, and so on. So Robin, I'm sure I would have not done the complete justice for the introduction, but I would love you to take it forward a little bit, give us a short introduction, and please go on with your session of what we're going to do. We will have about 30 to 40 minutes of presentation, a few slides that you've prepared for the entire audience. And at the end, we will get into a little bit more Q&A session and have it an interactive session with the audience. All yours, Rob.
Thank you very much, Karthik, and welcome everybody. We're here through the magic of technology, and I'm always amazed when it works. So I'm delighted to have you all here. As Karthik has said, I have been involved in a number of things. Just as a simple point, I happen to be outside of Boston, Massachusetts. Karthik is in California, and the rest of you are spread all over the world. So this is, I sometimes refer to this as a pack of lies about me, but there are a number of things that I have been involved in. I have not written books per se on testing and ROI, but I have developed courses and many articles. I do have a book called Discovering Real Business Requirements for Software Project Success. And but I've been involved in the area for a long time. What's especially relevant for this topic of testing is that I've been in a member of the IEEE Standards Working Group for IEEE Standard 829, which is a standard for software test documentation. And I was a member of the working group that developed the revision that came out in 2008, and in fact we deal with that in the course. I also recently finished working with IEEE Standard 730, which is the standard for software quality assurance plans. And we've made a major revision of that, and I'm very pleased to say that a number of the key concepts from my proactive software quality assurance methodology were incorporated within that. Now, we're going to be talking about testing, and I'm sure that many of you are familiar with testing, but perhaps it hasn't occurred to you that in a typical software project, testing takes about half of the time. And yet, very often it is not planned, it's not designed, and it's not managed, certainly not in a manner comparable to the way that development tends to plan, design, and manage. And developers, it's no secret, developers are interested in developing, not in testing. It tends not to be where their attention is. It tends not to be where their skill is. And that's especially an issue in agile development, where the developer is being relied upon increasingly to do a lot more of the testing. What's also important is that project managers, even though testing amounts to about half of their project and has a significant influence on their results, most project managers really are not all that familiar with testing. They don't know how to do testing. They don't know how to plan it, design it, or manage it. It's not an indictment of project managers. It's simply a fact. It's not an area that they tend to pay attention to. Now, one of the ironies is that to a considerable extent, people who are in quality assurance and testing roles, including those in quality assurance and testing management roles, also often don't have a whole lot of understanding of planning, designing, and managing testing. It's not a secret that developers make mistakes, and the development process makes mistakes. What most people on the development side don't appreciate is how many mistakes they actually make, many more than they probably realize. And the significance of this, of course, is that defects that are missed are major causes of project overruns, budget overruns, schedule overruns, and general unhappiness. It adds up to money. Everybody gets interested when we put money on the table. When we look at how development works, we have requirements. The developers have an understanding of the requirements which they implement in their code, and the testers have an understanding of the requirements that they implement in their tests. If the developer's understanding and the tester's understanding agree, that gives us a sense of corroboration, that gives us confidence that what's being developed is correct. If they are not the same, if the tester's understanding and the developer's understanding are not the same, then it could be because the developer is wrong, it could be because the tester is wrong, or it could be because both the developer and the tester is wrong. And not surprisingly, sometimes when the developer and tester have the same understanding of the requirements, they can both be wrong. So those are the sources of errors. And defects get created by the development process. But very often testers seem to be blamed for them because the testers are often the ones who detect the defects. Developers tend to make a lot of defects, a lot of mistakes, typically anywhere from 15 to 70 errors per 1,000 lines of code. Okay? And we often use the abbreviation KLOC, where K means 1,000 and LOC means lines of code. And the number of defects relative to some measure of size of the program, like lines of code or 1,000 lines of code, is referred to as defect density. There are two issues here. One is that developers make a lot of mistakes. The other is that developers tend not to be aware of how many mistakes they make. So the developers think that they've only made 1 or 2 mistakes and they're kind of minor and they've caught them all and they've fixed them, when in fact they very often only find anywhere from 25 to 75% of the defects, often on the lower end, and they think that they haven't made many mistakes and that they've caught them all. So there is this discrepancy in many instances between the developer's perception of how good a job is being done and the reality. And that creates difficulties. It creates difficulties from a software development process. It creates difficulties from a testing standpoint. And it creates difficulties from the project team working together, because the developers don't want to hear about the defects that they don't think they have. Now, before we get done breaking our arms, patting ourselves on the back, we need to realize that testers aren't perfect either, and that there are a lot of errors that get past everybody and get out to the users. Typically, somewhere between 3 and 8 errors per 1,000 lines of code, somewhere between 5 and 15% of the total errors often get out to the users. Capers-Jones, who's a very prominent software measurement guru, says that just statistically, the cream of the crop in the software world are the folks who deliver 5% or fewer of their errors to the users, to the customers in the field. Now that means that in the software industry, 95% quality, 5% errors, is considered good. But consider everything else that you deal with in life. Almost everything depends upon quality levels far higher than 95%. 99.999+% is what we rely upon in all manner of things. So when software is operating on a much different perception from what people ordinarily are accustomed to or depend upon, once again, we encounter some difficulties. Now, there are organizations that do orders of magnitude better, that have reported defect densities as low as 2/10 or even 4/100 of an error per 1,000 lines of code. Way, way, way less than 5%. Now, I'm telling you this for 2 reasons. First of all, to make you aware that it can happen, and secondly, to make you aware that the organizations that produce such higher levels of quality, such lower levels of defect density, are not doing the same things as the typical organizations that are delivering 5 to 15% of their errors to the field. The first thing that these organizations do differently is they measure. They know what their defect densities are. The other thing that they do is that they apply a lot of types of techniques that quality assurance and testing authorities advocate and that we describe in this course. There are a number of reasons why we have difficulty getting people to apply effective testing. If you look at some of these statements here, these are very common developer views. I'm sure that some of you have said these things. I'm sure that some of you have heard these things. You know, there is this concept that testing is boring and uncreative and that the creative part is development. Now, in addition, developers tend to take a linear view of development. Code, test, debug, done. That's the way they tend to view the development process. But in fact, it's not a linear process. It's an iterative process. And one of the reasons that developers tend to exceed their deadlines is because they expect everything to get done in a single linear path, and they're not factoring in time to redo things that were not correct. So let's consider this question of creativity. Which takes more creativity? Making errors that you don't know about? I would contend that practically anybody can make an error, and it doesn't take a whole lot of creativity to make an error. Generally, it takes more creativity to find those errors, and of course, the thing that takes the most creativity is making excuses for those errors when they show up in production. It's very common that people test with the objective of finding all the errors. And I will just caution you about that. For one thing, people will say, it's impossible to test everything. It's impossible to have code that has no defects. Technically, that's not true. What's impossible is to know for sure that you've tested everything and that you have no defects. Because the only way to know for sure that you have no defects is to know what all the defects are. And if you know what all the defects are, then indeed you don't need to test. But we don't know what all the defects are. So when we test, we need to make testing manageable. And that means instead of looking for the absence of errors, because you can never be sure that you've found all the errors, instead we need to define things in positive terms. And testing is confirming, not assuming that things are right. Sometimes developers have been known to assume that things are right because they've developed them. I know as a developer I've always acted in that way, and of course I've always been wrong. So we define in positive terms that it does what it's supposed to do and it doesn't do what it's not supposed to do, and that the various aspects of functionality and structure have been addressed. Because there are many more potential tests than we are likely to have time to run, we need to design our tests. And that's what this course is about. And we design tests to pick those tests that have the highest likelihood of detecting bugs. But realize, a bug is not doing what it's supposed to do or doing what it's not supposed to do. So we're defining in positive terms what's it supposed to do and what's it not supposed to do, and any differences from that is a bug. It's a little bit different from simply hunting for errors, because then our challenge is accurately and adequately identifying what it's supposed to do and what it's not supposed to do. That's the challenge that test planning and design undertakes. Now, if you run a test and it does not reveal a bug, is that test a failure? Some people would say yes, but in fact, if there is no bug, the test will not reveal it. There will not be a bug to reveal. So a test is a failure only if there is a bug that it should reveal and it does not. So there is positive value from demonstrating that things work properly and that things that are not supposed to happen do not happen. That's positive value, and detecting when those are not true is also positive value. When we test, there are a couple of concepts that we need to be conscious of. One of them is that as you test more and more, you find fewer and fewer additional errors. The number of defects that you find tends to taper off. Now, if you've ever experienced a situation where you were asked to write something, it might be a report or a letter or something like that, and you check your work and you might find some mistakes and correct them, and now you think everything is fine, and then you give it, say, to your boss, and your boss immediately finds a bunch of errors that you had not seen. It's hard for somebody to find his or her own errors. Our mind fills in gaps. And an independent tester can often see things that the developer or the author overlooks. we can take advantage of this concept to make testing more economical. So if we involve a second tester, when the first tester's ability to find additional errors is tapering off, together in a much smaller amount of time, together they are able to identify a larger number of defects that would have taken that first tester, whether it was the developer or just any first tester, much longer by himself or herself to find. So we have two concepts here. One is that an independent tester tends to be able to spot things that especially the author or a developer might not spot. So if you can have only one tester, it's usually better that that's an independent tester, especially if they have skills and training and like to test. The other issue is that if you add a second tester when the first tester's ability to find additional defects is tapering off, together they will find the total number of defects quicker than either by themselves. And similarly, you could add a third and a fourth and so forth, and that's in fact what happens in the typical development and testing process. In addition, when you plan and design the tests, it tends to make these testing activities more thorough. And this course is going to be describing my methodology, which I call proactive testing. And I think if you join us for additional sessions that you'll begin to see how proactive testing can find many more defects than traditional testing, which I call reactive testing. Proactive testing can typically find many more defects quicker and cheaper. It's a win-win situation. Now, testers are in a reasonably high demand role because many organizations recognize the need for testers. Some of them have learned it the hard way. During the dot-com era, testing, the need for testing really took off because a lot of organizations were jumping out onto the internet prematurely. But many organizations recognize the need for testing. And in the past 20 years or so, testing has really developed an identity. It's become recognized as a role in its own right. Previously, testing was kind of considered just a part of development, but increasingly testing is recognized as a separate discipline, a separate skill set, a separate profession. Now, in spite of this, and I will tell you that I interact with many, many testers at conferences and webinars and seminars and forums, and the fact is that when I interact or I have a chance to talk with testers, it's very common that when they're attending, for instance, a seminar like this, that many of them have had no formal training, that this might be their first formal training in testing, and that many have no real methodology to guide them. They may have a handful of techniques. Many people have just learned on the job by watching the guy next to them. And while that is a way to learn, it tends not to be very systematic or very thorough. So courses like this help fill those gaps provide some formalities, some systematic approaches, some methodologies. These things help. They help you be a more effective tester. They help you be more value to your organization. But simply taking a class is not the full story. You have to make it happen. You know, it's not just that you've taken a class or passed an exam or something like that. You still have to apply these concepts, and you need to practice them and improve them. So here are the objectives that I see for the remainder of this course. And by the way, we'll talk about the structure of the course, but if you're not aware, it's going to consist of a total of 12 sessions, each approximately 1 hour, spread out over a period of about 3 weeks. So first of all, we want you to be able to describe a structured, proactive testing model. Now, a model is a mental picture of how things fit together. And when you have that mental picture, that makes the techniques and the concepts much more workable and makes it much more feasible for you to adapt. Now, proactive testing is something that needs to be performed throughout the life cycle. The bulk of testing gets carried out after the code is written. But when we get proactive, we do things at each of the key points in the development life cycle. And whereas much of testing, much of traditional testing, turns out to be resisted by people, by developers and users and managers, proactive testing tends to help cut their time, their effort, and their aggravation. And because of that, they tend to be much more supportive and even advocates of it. One of the reasons is because proactive testing, while it uses proven testing techniques, also applies special, more powerful methods of planning and designing the testing that enable us to spot many risk conditions that need to be tested that traditional testing and traditional development ordinarily overlook. We want you to be able to be familiar with some industry-accepted techniques or test plans, test designs, and test cases, and apply some methods that will help you increase the success of your testing. To be able to use these various test plans, test designs, and test cases in efficient and effective ways, not as ends in and of themselves. And we want you to be able to use your limited time and resources to quickly and reliably identify and focus on testing the highest risks, and not only test them more, which is what traditional reactive testing does, but also be able to test them earlier. Because when you can catch problems earlier, it's easier and cheaper to fix them, and you end up with a far better result. Now, some people say, well, what are the prerequisites to this course? Basically, if you are listening now, there's a good chance that you're perfectly qualified to attend. There is no real prerequisite. There's no formal course or academic requirement or anything. You know, we are looking for people who have interest. Now, let me describe to you the topics that we're going to address. And I want you to be aware that there are many, many concepts and techniques that we're going to be covering over the 12 sessions, many more than you are likely to have time or energy to address immediately. And so I want you to think like a cafeteria. Think as if you're in a cafeteria. I'm sure you've all eaten in cafeterias. And when you go into the cafeteria line, you see all of the things that are available. You decide which are the things that I want to get to eat right now. And so you pick what you think you're going to eat at that moment. But then you say, well, but I see that dessert there. That looks awfully good. Let me remember that it's there, and if I have more room when I'm done with what's on my tray, maybe I'll come back and get that dessert as well, or an extra salad, or whatever. So you're thinking immediate term, you're thinking short term. And then, as you're going through, you're saying, well, gee, you know, I see that the fish looks really good. I think I'll have the fish today, but the chicken looks good too. Maybe I'll get that tomorrow. And so you're thinking not just for the immediate and near term, but also the longer term. In addition, realize that every one of the concepts and techniques that we're talking about can be applied by you as an individual. You will get more benefit if your team applies the concepts, if more people are involved. And there will be even greater benefits if the whole department or the whole division or whatever applies it. But the more people that there are to involve, the more difficult it is to involve them. And so you need to be judicious. Don't not do something because you can't do everything. So pick the concepts that you want to apply right away. Pick the ones that you might want to apply there right immediately thereafter. Keep in mind the ones that you're probably going to want to apply later. And focus on what you can accomplish. If you're the only one who can do it, fine. If you can get other people to do it, fine. If you apply methods and get better, other people start being influenced by you. That's a big way that we spread ideas. Now, let's look at what the various sessions are. And each session, as I said, runs about an hour. And each one is going to be at this time period, 5 p.m. Pacific, 8 p.m. Eastern Time. Okay. So what we're doing tonight is the free orientation, where we're talking about the value of testing, and now we're looking at the course topics. The next session, referred to as a demo, it's also free. It's going to be in about a week and a half, and it's talking about the benefits of proactive testing. So we're going to be talking about the sources and economics of defects, why traditional testing is reactive and less effective than needed, and how proactive testing can offer some different and, frankly, more effective approaches. And then we're going to be looking at proactive testing and the proactive testing life cycle. We're going to be looking at key testing concepts, including different types and levels of testing. And then we'll see how proactive testing addresses all of them within the context of the development life cycle. Then we're going to be looking at risk, because all testing is risk-based, whether or not it's called risk-based. Okay? And that's because risk, so testing is our main means of reducing risk, and therefore risk becomes the basis for prioritizing among the many potential tests, which are the ones that we're going to run in our available time and resources. And we're going to see ways to quantify risk and how proactive testing uses techniques that help identify risks that traditional reactive testing and its risk analysis tend to miss. Then we're going to look more about the differences between proactive and reactive test design. We're going to be talking about the IEEE standard, IEEE, the Institute for Electrical and Electronics Engineers, IEEE standard 829, which I mentioned previously, which provides a structured approach to planning and designing tests, and will distinguish how traditional reactive testing might use that compared to the added benefits that proactive testing gets by applying it in different, more effective ways. We're also going to be using a case study for doing exercises, and we'll introduce the case study at this point. And then we're going to get into doing some master test planning risk analysis, identifying large risks. Large risks that ultimately turn into what are called detailed test plans. Large risks, when they come true, very often become showstoppers. And we're going to see how testing can drive development when we're proactive. That's something that you can't do when you're reactive. Then from the master test planning, then we're going to get into identifying needed test designs. The master test planning identifies detailed test plans. We'll use one of those as an example to drive down to identifying the test design specifications that are needed to give us confidence that a particular detailed test plan works. And we'll be looking at both black box and white box approaches. And we're going to use a technique, a powerful technique called a functionality matrix that helps us identify the test designs that we need. And we'll be looking at ways to test use cases. And use cases are a popular format that many people use for describing requirements and designs, the ways that programs are supposed to work. Then we're going to get into a whole bunch of specific lower-level test design techniques, including checklists and guidelines. But we're going to be using them in ways that are more powerful than people traditionally use them in traditional reactive testing. And as a result, you're going to be amazed at how many tests that are ordinarily overlooked we identify. Now, this is a big topic, and we're going to spread it over 2 sessions. So we're going to be looking at some additional techniques. And in this session, we're going to be looking at some well-known techniques like equivalence classes and boundary testing and decision trees and decision tables. And we're going to point out a couple of pitfalls in those common techniques. Okay? Now, then we're going to be making test designs more reusable, and